Hello, Mahdi. How are you today?
Hello,
Are you? Have you had a long day or a
I'm
long
good.
week?
How are you?
I'm happy to be here. I went out for a walk there. Just happy to be here and to be teaching you. Have you had a busy week then?
Yeah.
Busy week. Okay. Well, welcome back to another lesson. I'll hopefully not. We'll take it in steps. So, but before we have any do any activities on trigonometric ratios, which we've been looking at previously, I'm going to do some warm up activities, just to get you thinking. So, I'm going to share my screen, Maddie. Okay, and
Okay.
I will give
Yeah.
we'll give it. Oh, sorry, 2 seconds. Um, I need to share my entire screen. Yeah. Okay. Is it just me, or is it a warm day? It's very warm today, isn't it? Okay, so
Yeah.
yeah, it's a very warm day. Okay, sorry, I'm just checking the connection. Okay, so this first activity, it's titled "Come to the Party." Can you see it?
Yeah. I can
Okay.
see it.
Okay,
Yeah.
so there is a present for all the places around this table. First, do the sums written on each present, then draw a line joining up the presents with the right people. So the presents are below, so you want to join them up. So if you want to do the first present there, I will.
Um. So 1 divided by 1 would be at
Would be what? Sorry.
1.
Yep. So I'm going to get an arrow there. Okay. Next present. Um.
25 divided by 5 would be at 5.
Okay. So I'll just get my arrow. Okay. And the next present
16 divided by 2 would be at 8.
would be 8. I heard my voice echoing there. And again. Okay, and the
Um,
next present.
4 divided by 2 would be 2.
Okay, so get my arrow. 2, and next.
27 divided by 3 would be 9.
27 divided by 3 would be 9, so I'm just going to get my arrow. Okay, now please. Yes, it's going to work. Okay, and next present. Oh, sorry. Next present.
Uh, 1 times 2 would be 3.
Okay, brilliant. Okay, would be 3. Yep. Okay, and next present.
14 divided by 2 would be 7.
Okay, brilliant. Thank you. And then next present.
12 divided by 2 would be 6.
Okay, 6. Um, and then there's our. This is getting a bit messy, but anyway. Last present.
12 divided by 3 would be 4.
Okay, 4. Okay, so the presents have been each allocated to the right person. Well done, thank you. Okay, moving on. This next activity. So school starts today. So you had school today, didn't you, Maddie?
Yeah.
Okay. What's your school? Does your school start at 8:45 then?
It starts at 8:40.
Do you go to assembly, or
Um,
or form class?
for, it depends on which year you in. So on Mondays it's year 11s, Tuesdays it's year 10s, Wednesday it's year 9s, Thursdays is year 8s, and Fridays year 7s, and that's the days that the people have assemblies.
Okay, so you would have gone to your form class then today because you're
Yeah.
you're year 10. Okay, so
Yeah.
school starts today, but first each teacher needs to know where they are supposed to go. Okay, so can you help by doing the sum on each classroom door, then draw a path for each teacher to take? So this is just all you have to do here is work out, do the sum, and then I'm going to join, get an arrow, and well, that's the classroom door that each teacher has to go to. So what about the first sum, the first door?
So 7 times 2 would be 14.
Okay, so the last, the fifth teacher goes to classroom door 14. Okay, and what about the next door?
6 times 4 is 24.
Okay, the first teacher goes to the classroom door 24. And what about the next sum?
Um, 6.
Okay,
54 divided by 6 is 6.
okay, so the fourth teacher goes to classroom door 6. And what about the next classroom door?
70 divided by 10 is 7.
Okay, so the second teacher goes to classroom door 7. And then what about the last classroom door? Last classroom door.
Um, 8 divided by 48 is 6.
Okay, hold on. We've already allocated. We need to double check this one. We've got. Did we not match up 6 to classroom door 3? Hold on. We need to check our sums here, don't we? So we'll get the calculator in a minute, because 54 divided by 6 is 9. Okay. Did you say?
9.
Yeah. So it's actually.
Yeah.
So let me just. So the fourth teacher goes to classroom door 6. Yeah.
Yeah.
And the third teacher would actually has gone to well, she needs to be allocated to the right classroom door, so she would go to classroom door 9. Okay, so all the teachers are going to the right classroom doors. And you wouldn't, and you probably experience this yourself in school, especially with a new substitute teacher. Sometimes they go they end up in the wrong classroom. It can happen. Uh,
Yeah.
okay, so well done. Moving on. Okay, lots of parcels. So I think in one of my lessons I mentioned about Amazon. So pretend we're an Amazon driver here. So each parcel has a different sum written on it. They've got here postman, but we're gonna go with Amazon driver. Before the Amazon driver can deliver the parcels, you need to solve the sums and then draw a line connecting each parcel to the right house. There are two parcels for each house. Okay, so we've got parcels here. So with that, I'll not draw the arrows. I'll just let you do the sums. And okay,
Okay, so 9 times 2 is 18.
okay,
And then 6 times 3 is 18.
okay. So both go to 18.
Oh, sorry.
So 9 times 2 is 18. Six
Eight,
times three.
yeah. 6 times 2 is
Yeah,
um
6, 12,
8,
18. Yeah,
18.
yeah.
Yeah.
And then 4 times
4
3.
times 3 is 12.
Okay, and then the next parcel.
5 times 2 is 10.
Okay, yep, 10.
20 divided by 2 is 10.
Okay, and then
8 times 2 is 16.
yep, 16. And then the next row.
Um, 2 times 6 is 12.
Mm-hmm.
10 times 2 is 20.
Okay, so 12, and then we've got 20. Yep, and then 6 times 5.
6 times 5 is 30.
Okay, 30's at the end of the row there. Okay, last row.
4 times 4 is 16.
Okay, where's 16? 16 is house number 3. And then next one.
3 times 10 is 30.
Okay, where's 30? Yeah, 30's at the end of the row.
And 5 times 4 is 20.
20, okay. Brilliant, thank you. Okay, and this is the last activity here, octopus legs. So, you know that an octopus has 8 legs, okay? There you can count them there.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. So, how many legs are there on 3 octopus? Well, on 3 octopus. So, this is how you would work it out. 3 octopus times 8, so, you know, 8. Each octopus has 8 legs, so that'll be 24 altogether. So how would you work out how many legs on 5 octopus? So
So you write 8
where would the 8 go?
and before octopus.
Well, actually, would that not be 5? Because there's 5 octopus.
Oh yeah,
Yeah,
yeah.
5 octopus. Okay, multiplied by how many legs?
8.
8 legs equals
Um, that equals 40.
40. Okay, and how many legs on 7 octopus? So how many octopus?
So we do 7
Okay, 7 octopus.
times 5 legs.
Uh, no. How many? So each octopus has eight
Oh, sorry.
legs.
8 legs.
Yeah,
8 legs.
and then all together equals.
Altogether, that's 56.
Okay, and moving on. So a spider also has 8 legs too. Draw. Well, without drawing we don't need to draw the legs here. But I want to, or maybe I could quickly do. Let me see. Can I do it quickly? No, it's going to take up time. So what I'm going to do is, um, well, first of all, count how many. Now they are smiley faces there, but I think those smiley faces represent spiders. So how many spiders are there?
There are 6 spiders.
Okay, 6 spiders. How many legs do you draw in total if each spider has 8 legs? So
Um,
we've got 8 spiders multiplied by 6. How many legs?
um,
So 8 spiders multiplied by 6 legs.
48.
Okay, 48 legs. Okay, so just some warm up activities. So I'm going to come back. Hello. Um, so I'm back again on camera. Um, so what we're going to do now is what we were here to do is trigonometric ratios. Are you ready?
Yeah,
Okay, so trigonometric ratios. Do you have your notes?
yeah,
Do you have your pen?
yeah.
Do you have the calculator?
Um, I can use my phone's calculator.
Okay, I'm happy with that. So let's start. Let's start the ball rolling then. Okay, so first question: find the sine of LT. So what do you know already about sine? What's the how do you work it out? Sine.
You do for sine. You do opposite over hypotenuse.
Opposite over hypotenuse. Okay, tell me what we need to do here. So opposite would be,
Opposite would be 12.
yep, and hypotenuse.
Would be 5.
Oh, no, hypotenuse is, remember hypotenuse
Oh,
is the
sorry.
long,
Hypotenuse is 13.
yep, because it's the longest leg. Can we, hello, is that who's that?
My little brother.
Your little brother, hello. Um, okay, so can we simplify this?
Um, no.
Okay. So 12 over 13. Yeah, brilliant. Well done. And the next question. So it's sine again.
So sine is opposite over hypotenuse. So we would do um 15
Okay, that's the opposite. And hypotenuse.
over 17.
Okay, and can we simplify this?
Um, No.
Okay, no. 15 over 17. Super. And the next question, we've got another sign. So opposite over hypotenuse.
So we do opposite over hypotenuse again.
Mm-hmm.
So opposite is 35 and hypotenuse is 37.
Okay, and can we simplify this?
Um, no.
Well done. And okay, another sign. Okay, so again.
So opposite over hypotenuse again. So that would be
Oh, sorry, I'm doing it for you.
20. Yeah,
20.
24
Mm-hmm.
and then 26.
Okay, and can we simplify it?
Yeah.
So how do we do that?
So it would be 12.
Okay, so we divided it by 2,
Yeah.
and this bottom number, this hypotenuse, would become
13.
13. Okay, submit. Yes, that's right. Well done. Okay, and now we've got COS. So what is COS? How do you work COS out?
Cos is adjacent over hypotenuse.
Adjacent. Okay, adjacent over hypotenuse. So walk me through it.
So adjacent here would be 36.
Mm-hmm. And hypotenuse would be
85.
okay. And can we simplify this?
Um,
I can hear your wee brother. Okay, um, let me say, is he on the camera? No. Okay.
um,
Okay. Okay. Sorry. Yes. Back to this question. Can we simplify this?
um, the screen's frozen.
Oh no! Seriously? Oh dear. Hold on a minute. I'll stop sharing my
Oh,
screen.
yeah.
Okay.
Yeah, I can see it now.
Okay. So can we simplify this?
Um, no.
No. Okay. Submit. Terrific. And what about oh, we've got another COS. Okay. So
So for cos we do adjacent over hypotenuse again.
okay. So adjacent over hypotenuse. So adjacent is
Adjacent is 6.
yep. And hypotenuse would be
10.
okay. And can we simplify this?
Yeah.
Okay. So 6 would become
3.
so you've divided it by 2. Yep. And then
Yeah.
divide 10 by 2 and you get 5.
5.
Okay, keep it up. You're doing very, very well here. You're impressing me already. So, but these get harder. You know, they get harder.
Yeah.
So, okay. So
So tan is opposite over adjacent.
opposite over adjacent. Okay, so opposite is
Opposite is 60.
yep, and adjacent is
32.
okay. And can we simplify this?
Yeah. So 60 would become 30.
Yep.
And 32 would become 16.
Can we go even lower?
Yeah. So 30 would become 15.
Okay, and 16 would become
And 8.
okay. 15 over 8. Okay, 15 over 8. Good work. Well done. Okay, so we have tan again. So tan,
Is opposite over adjacent.
yep. So opposite over adjacent. We've got, so tan D. So opposite would be,
30.
okay. Now, adjacent would be,
We need to solve what adjacent would be.
DF. So we need to solve DF. So can you walk me through, so what do we do here? We need to apply what? The theorem? Or we need to get a,
The Pythagoras theorem.
yes. which is
Um, so for this, we would do c squared minus b squared equals a squared.
mm-hmm.
So c squared is the hypotenuse, which is 34.
Yep.
And b squared is the opposite, which is 30.
Yep.
So now I'd need to figure out what 34 squared and 30 squared are and subtract them.
Yep.
So 34 squared is 1156.
1156.
Yep. And 30 squared is 900.
900. So take them away.
So 1156 take away 900 is 256.
Okay, the square. Now you need to find out the square root of. Did you say 256?
Yeah.
Okay.
The square root of 256 is 16.
Okay, so that means that the length of the adjacent is 16.
Yeah.
Okay, so can we simplify this?
Yeah.
Okay, so what do you do now?
So 30 would become 15.
Okay, and 16 would become?
8.
Well done. Brilliant. Okay, and the next question, so we've got sine. So
sine is opposite over hypotenuse.
it's opposite over hypotenuse. So opposite is missing, hypotenuse is 74. So
Yeah.
what do you do here then?
So we would do c squared minus a squared equals b squared.
Okay, so the b square will be the hg, the length of hg.
Yeah.
Yeah.
Yeah. So c squared is the hypotenuse, which is 74.
Mm-hmm.
And a squared is the adjacent, which is 24.
Mm-hmm.
So now I would find out what 74 squared is and what 24 squared is.
Mm-hmm.
Subtract them by each other.
Yeah.
So 74 squared is 5,476.
5,476. Yeah.
Yeah. And 24 squared is 576.
576. Okay, so you take them away from each other.
So 5,476 take away 576 is 4,900.
4,000. Okay, now we need to find the square root of 4,900.
The square root of 4,900 is 70.
70. Okay. Oh, 70. I will type in now. So Mahdi, can we simplify this?
Yeah, so 70 divided by 2 is 35.
Okay, 35.
And 74 divided by 2 is 37.
Is 37. Okay. And can we go any lower?
No.
Submit. Well done. Okay. And next, okay, we've got sine. Okay.
Okay, so sine is opposite over hypotenuse.
Opposite over hypotenuse. So sine B, so opposite to B is
56.
okay. And hypotenuse is
Hypotenuse is 65.
okay, so we've got the numbers. Can we simplify this?
No.
Okay. Well done. And the next question, COS.
So cos is adjacent over hypotenuse.
Okay, so adjacent to T is
Is 45.
no adjacent. No, that would be opposite.
Oh, adjacent. Adjacent is 28.
Okay, and hypotenuse is. Did you say adjacent over hypotenuse for COS?
Yeah.
Okay, so hypotenuse.
Hypotenuse is 53.
Okay, and can we simplify this?
No.
Okay, so you said no. Well done. Okay, so next. Okay, we've got COS again. So what was
So
COS?
cos is um, cos is adjacent over hypotenuse.
Okay, so COS C. So adjacent to C is
Adjacent to C is 48.
okay, and hypotenuse. Well, the is
So for hypotenuse, we do a squared plus b squared equals c
yeah,
squared.
to get the length of BC.
Yeah. So a squared is adjacent, which is 48 squared,
Yep.
and then b squared is the opposite, which is 55 squared.
Okay.
So I would add those numbers up.
Well, did you square?
So
Did you square them first? Did you square 48? What's 48 squared?
so 48 squared is 2,304.
2,304. Add 55 squared.
Add 55 squared, which is 3,025,
3,025.
and 3,025 plus 2,304 is 5,329.
Five. Okay, the square root of 5,329. Did you say?
Yeah,
Okay,
is 73.
73. And can we simplify this? Hmm.
Um, no.
No, we can't. Okay. Submit. Super duper. Okay, now they're getting a bit harder. So let me see. Yeah, a minute. Have you? So make sure you've got. Sorry. Make sure you've got your calculator because these. You need to find the square root here. So you've got sine again. So sine is. Oh, here. Actually, for this question, write your answer as an integer or as a decimal rounded to the nearest hundredth. Okay, so slightly different word of question. So, um, but it's the sign. So, what do you do
Um,
for sign?
is there an example for this question?
I don't think they. Well, I can't actually get access to the example because we've already started the questions. However,
Oh, okay.
I think wasn't this didn't we do a similar one in the previous lesson?
Yeah.
And didn't we work it out? We used the sign. How do you so what? How do you work out sign again?
So sine is opposite over hypotenuse.
So okay, opposite over hypotenuse. So it'll be 3 square root 11 over 2 square root 33. Did you not write here, Maddie? Did you not write out the? I think you wrote it out at one point. The
Yeah,
example.
I think I did.
Yeah.
Yeah. Okay.
Okay,
I got it.
happy days. So can you see the question?
Um. No.
Oh no. Okay, so it's share entire screen again. You should be able to see it
Yeah.
not.
I can see
Okay,
it now.
good. Okay, so you found your notes. So walk me through it. Uh, so sine.
So first, what I did was 33 squared. Oh, sorry. Square root of 33.
Okay. Wait, hold on. Um, so we know first of all it'll be 3 square root 11 over 2 square root 33. That's to find the sine.
Oh,
What,
yeah.
what so what is that not what you do first? You have to do Pythagoras' theorem first to get what do you have in your notes? Did you
Um. I wrote square root 11,
okay. Do
and
you know what I'm
then
going to do? I'm going to actually do you think it might be helpful to look at the answer here?
yeah.
Okay, so I'm going to put 0 down. It's 0.87. Okay. That was the answer they were looking for. Okay, so we know sine is opposite over hypotenuse. Okay, so the opposite here is the 3 square root 11. Okay, and the
Yeah.
hypotenuse is the 2 square root 33. So, uh, so that's what they've put down. In do you see? Do you see the 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 plug in RT equals 3 square root 11 and ST equals 2 square root 33. So
Yeah. I see that.
so you need to first of all you need to find out what 3 square root 11 is. Can you do that for me and see if you can get the right answer, the same answer? So take the square root. You need to find out.
Yeah. I got the same one.
So what did you type in your into your calculator?
So I wrote 3 square root then 11.
Okay, and what did it give you?
3.3166 and then 2479 and then some other different numbers.
Okay, and what? Okay, do the same for 2 square root 33.
Okay. So I got 5.7446
Okay, yep.
or 5 then 6, but because of the 6 you would round up to 6.
Okay. Sorry, you got 5.7445.
Yeah. 5 6.
Okay. And then you multiply, don't you? You multiply. So do you see the 3? The
Yeah.
number 3. Okay, so then you multiply that by 3? So then you would get 9.9498. Okay, sorry. See when you're working out the square root 11,
Yeah.
you've got that number and then you multiply it by 3 and you should get 9.9498.
Yeah.
And then the same thing for ST, it's 5 2 multiplied by 5.7446 and you should get 11.4892. And then you divide 9.9498 by 11.4892. Yeah?
Yeah.
And what do you get? Have you typed those,
Um
find out what you get? What do you get?
so 9.9498 divided by
11.4892.
892 is 0.8 0.8660.
Okay, and now you need to. So that's what you get when you divide those numbers, and then you need to do get it to the nearest hundredth. So sin s is approximately 0.87 because six is what is six?
6 is big enough to round up.
Okay, so then the six before that becomes a seven. So okay, so hopefully you understand that now a bit better now, yeah?
Yeah.
Okay, so let's go back to the questions. So tan, can you remember what tan is?
So tan is opposite over adjacent.
So tan u, so opposite to u.
So opposite is 4.
Yep, and ut is missing the length for ut, so we need to apply Pythagoras' theorem.
Yeah. So what we would do is c squared minus b squared equals a squared.
Yeah,
So c squared is the hypotenuse,
yep.
which is 5 squared,
Mm-hmm.
and then b squared is um, b squared is the opposite, which is 4 squared.
Yeah.
So 5 squared is 25, and 4 squared is 16.
Okay, so you need to subtract those numbers.
So 25 minus 16 is 4. No, not 14. 9.
Okay, so the adjacent. Okay, so then you need to do. What do you do with the nine?
You find the square root.
Mm-hmm.
So square root of 9 is 3.
Okay, so it'll be 4/3 for tan u equals 4/3. Yeah.
Yeah.
So opposite over adjacent. Brilliant. Okay, and the next question we've got cos.
So cos is cos is adjacent over hypotenuse.
Adjacent over to r. Adjacent to r is missing. R,
So
missing,
yeah, so
and hypotenuse is 89. Okay,
yeah,
what do you do here?
so we do c squared minus b squared equals a squared.
Mm-hmm.
So c squared. So first I would do 89 squared, take away 80 squared.
Mm-hmm.
So 89 squared is 7,921.
7,921.
Yeah, take away 80 squared, which is 6,400.
6,400. Mm-hmm.
And then, so 7,921 is
Minus six.
6,400.
Yeah, minus 6,400 is
And that's 1,521.
one. Okay, so the square root of 1,000. Did you say 1,521?
Yeah. And the square root of that number is 39.
39. Okay, and can we simplify this?
Um,
Let's see.
no.
Okay. Well done. Okay, now we're back to the harder ones. There's a bit of background noise. Are you able to close your door there? Or
Yeah,
okay,
I just closed it.
okay, thank you. Okay, so let's get back. Can you see the question?
Yeah.
Okay.
So again, we do Pythagoras' theorem. So
Well, first of all, tell
now
me
it,
what's well. Tell me what sin or sorry sine is. Tell me what sin.
sin is opposite over hypotenuse.
Opposite over hypotenuse. So opposite to s is
Opposite to s is 2 square root 33.
okay, and so that's opposite and hypotenuse. S R the length of S R is actually missing, so we need to find out how the length of S R
Yeah.
the hypotenuse. So what do we do?
So we would do Pythagoras' theorem.
Mm-hmm.
So that would be a squared plus b squared equals c squared.
Mm-hmm.
So we do 2 square root 33, and then we would do 6 square root 11.
Mm-hmm.
So what we would do is, so we would add the numbers up that we find.
Well, first of all, we need to find out, don't we? Do we not? The
Yeah, so
uh,
2
yes. Uh-huh.
square root 33 is 5.744.
Okay, and 5.744.
Yeah. And then 6 square root 11 is 3.316.
Okay, so you add them up.
Yeah, so 5.744 plus 3.316
Mm-hmm.
is 9.06.
And what comes after the six?
Nothing else.
Okay, 9.06. So the SR, so the length of the hypotenuse is 9.06.
Yeah,
Okay, now what do we need to do here now? So we know um, sine equals opposite over hypotenuse. So
yeah. So
we need, what do we do now? So
so now we need to find out what the opposite is.
no, we put the opposite over the hypotenuse. Do we not need to find? Do we not need to? What have we got written down there? Do we not need to find out the square root of 33, and then you
Um,
multiply it? What? Do you not need to find out the square root of 33,
um,
and then then you multiply it by two, and then you divide both the, and then you divide the opposite over on the hypotenuse. Yeah. Do you remember from the
yeah,
previous question? Okay. So
yeah.
what are you doing? What are you doing now?
So now I'm doing 33 square root times
We'll find out what that is first of all.
times
Find out.
2.
We'll find out what 33, the square root of, or find out what that is in numbers. The square root of 33.
So square root of 33 is 5.744.
5.744. And what comes after the four?
5.
Okay, keep it like that, because I think they had four numbers in the example after the decimal point.
Yeah,
And then so you've got now you've got 5.7445. Did you say?
yeah.
And over what?
So that'd be over 9.06.
For the hypotenuse.
Yeah.
Mm-hmm.
And then I'll times the numbers.
Okay. I'm just thinking back to the example, but in this one we didn't have. In this one here we didn't have. Uh. Well, in this one the hypotenuse we didn't. They didn't give us all of the. This one we had to figure out what the hypotenuse was. So what are you doing? You're multiplying the two by what?
Um, so um, I think I did something wrong.
What did you? What's wrong? What did you do wrong?
I'm just trying to figure it out.
So you found out the. Sorry, the screen's going again. You found out what the square root of 33 was, and now you've got it. You've got that. You've got over the
Oh, okay. I think I know what I did wrong. So I think for 5.7445, I need to times it by
two.
2.
Yeah, that's
Yeah, so 5.7445 times 2 is 11.489,
okay.
and then 9.06 times 6 is 54.36.
Did you divide?
Um,
Did you divide the
I,
number?
ta- I times the. Oh wait, I can't see the screen.
Oh dear. Right, hold on. Should be able to see it now.
Yeah.
Hold on, Maddie. I'm gonna have to. Let me just mute myself. I have to go downstairs. Okay.
Okay.
Actually, I've just gone into the other bedroom. Actually. So, yeah. So I need to share my screen. Okay, so I'm just sharing my screen again. Can you see the question?
Yeah. So I got So I divided 11.489 by 54.36, and I got 0.2114. 114.
0.214, and we need to round it to the nearest hundred,
Round to the nearest 100.
which would be 0 point.
0.21.
Okay, let's see. No, they're going to give us the answer anyway. Oh, not quite. I think I know what you didn't do. Oh wait, hold on a minute. So they've given us 22.9783 for the hypotenuse. What did you get?
I got for the 9.06.
Did you huh, okay. Now hold on a second. So RT over RS, so opposite over hypotenuse. So the opposite was 2 square root 33, and but we needed to find out what the hypotenuse was. So what they did was what you got something um let's see. What did you do? Can you see where you went wrong? I can't see your notes.
Um, I think what I did wrong was when I was doing 2 square root 33. I think I must have mistyped it on the calculator.
Okay. So what they didn't do here, see the way they've multiplied they found the square root of 33. They didn't multiply both number. Do you see that? They only multiplied
Yeah,
they don't do it for both numbers. So what you think you just typed it in wrong?
yeah, I think so.
So square root 11. Uh, type that into your calculator, and what do you get?
6 square root 11, I get 3.3166.
And multiply 3.3 or multiply that by itself.
So 3.316. So I would do 3.3166 times 3.3166.
Right. So and try it and see what you get.
10.9998.
Hold on. Hold on. Hold on. Hold on. Plug 6 square root 11 plus 2 square root 33. Okay. Can you type it in like that with the power of 2 by the power of 2 there? Can you type it in like
6
that?
square root 11 power of, no.
Right. Because well, or can you do 6 square root 11 multiplied by 6 square root 11?
6 square root 11
Mm-hmm.
times 6 square root 11 is 36.4828.
36. Right. And what? Hold on a second. We need to figure out how they got 396. Um. So according to them, where we went wrong, I think, is the Pythagoras' theorem element of it. Okay. So
Yeah,
we know that a squared plus b squared equals c squared. Yeah.
yeah, yeah,
So the r c squared was missing. So you just add them up. So you said so 6 square root 11. Can you find out what that actually is equivalent to? Like what that equals?
sorry, could you say that again?
What does 6 square root 11 equal? How can you get that into numbers?
So 6 square root 11 is 3.3166.
3.3166.
Yeah,
Okay, so what do you so they've got it squared here, don't they?
yeah,
3.3166. So see the way that 6 is beside the square root 11? What does
yeah.
that mean? Does that mean that you multiply those two numbers? So you need to find out what the square root 11 is first of all,
Uh,
because they've got here 396 for it. I'm trying to because I don't have the calculator. You see, I can't. How do you think so? Do they figure out what the square root 11 is first of all? And you got 3 point. What did you get for the square root 11?
so I did square root 11, and it also says 3.3166.
And do you multiply that by the 6?
Um, no,
So how did
because it
they?
says 19.8997.
Okay, so they've obviously squared that. Do you see? They whatever number this. So they've squared
Yeah,
6 square root 11 equals 6 square root 11 multiplied by 6 square root 11, and they've gotten 396 or yeah 396. So what about could you try the same? Could you try to figure out how the 2 square root 33 how they got the 132?
so 2 square root 33 Um,
Do you know what I think? Did you get anything there?
yeah, so 2 square root 33 is 11.489.
And what if you right? I multiply that by itself again. 11.489. What?
Okay, so when I multiply that by itself, it's um, it's 132.000001.
Yes, yes, that's exactly what they got. Brilliant.
Okay,
Okay, so we're going.
yeah.
We're doing something right. So if they're do the same for the six. So do the same for the 6 square root 11.
Okay, so 6 square root 11
Mhm.
is 19.899748
And
742. So multiplying it by itself is
mhm.
0.74.
I can
Eight.
hear is that the siren? I can hear the sirens there.
Yeah,
Okay, is that the place then?
and that is 395.99999.
Yes,
So
yes,
396.
yes. That's it. So you round it up to the whole number. So 396. Okay, that now we know what to do, don't we? So, will we keep going? You've got a bit more time to work on this. Is that okay if we could do?
Yeah.
Okay, so let's keep going. So cos.
Okay, so cos is adjacent over hypotenuse.
Okay, adjacent.
So adjacent would be 20,
Yep, and hypotenuse would be. We need to find out what hypotenuse is.
and yeah, so so what we would do is a squared plus b squared equals c squared.
Mhm.
So a squared would be the adjacent, which is 20
Mhm.
squared, and then the b squared would be the opposite, which is 48
Mhm.
squared. So 20 squared is 400.
400. Okay. Plus
Add
48.
48 squared,
Mhm.
which is 2,304.
Okay, and what do you get if you add them up?
So 2,304 add 400 equals 2,704.
Okay, so find the square root of 2,704.
So the square root of 2,704 is 52.
Okay, and can we simplify this?
Yeah.
Okay.
So 10
Hmm.
over 26.
Mm-hmm. And can we simplify it further?
Yeah, so 5 over 13.
5 over 13. Okay. 5 over 13. Let's see. Yes, we're right. Okay, and what about this one? Sine again?
So sin would be
Sine B.
Would be opposite over hypotenuse.
So opposite.
So opposite is 12.
And hypotenuse is missing. So what Pythagoras' theorem?
Yeah, so a squared plus b squared equals c squared. So a squared is the adjacent, which is 5 squared, and then 5 squared plus 12 squared. So b squared would be the opposite, which is 12. So 12 squared. So 5 squared is 25, and 12 squared is 144.
Okay, 144 plus
Uh, is 169.
106. The square root of 169
Is hold on. Is 13.
Okay, 13. So 12. Can we simplify this?
No.
Okay, 12 and 13. Okay, well done. Now, next one. Tan. Okay, this one
So
here. This one here is slightly... Okay, so same thing. Write your answer as an integer or as a decimal rounded to the nearest hundred. So what do you know about tan?
so tan is opposite over adjacent.
So opposite over adjacent. Opposite. ED is well, blank.
Yeah, so it's blank. So
Adjacent is 7. So
adjacent is 7.
so you need to find out what opposite is first of all.
So what we would do is c squared minus a squared equals b squared. So c squared is the hypotenuse, which is 14, and then we add squared, and then the a squared is the adjacent, which is 7, and then we'd add a squared. So 14 squared is 196. And 7 squared is 49.
So take them away.
So 196 take away 49 is 150.
Okay, so what is the square root of 150?
The square root of 150 is 12.247.
Okay, 12.247.
Yeah, but 7 is big enough to round up, so it'd be 12.25.
Okay, 12.25. Okay, now what do we do?
So now
12, divide them, don't we?
Divide them.
Or do you remember from what we do with tan? Did we get as far as tan when it comes to finding the integer when we're trying to answer it this way? Did we get as far as tan?
No, I don't think so.
But so we don't have square root this time, so do we just divide the numbers then? So tan is what? Tan is opposite over adjacent, is it?
Yeah.
Okay, so do we just... Is that what we do? Do you divide the numbers? If you divide the numbers, what do you get? What? Because I don't think we got as far as tan when it came to this.
So 12 divided. Okay, so 12.25 divided by 7 is 1.75.
What's after 5?
There's nothing after 5.
Right, well, we go with this one and see what IXL gives us.
Yeah.
1.75. Oh, we were close. We were so close. 1.73. We were nearly there. So close. Now, what did we do wrong? How did we go wrong? We did the right. Oh, did you only put in? I know what you did. Did you only go for? You didn't put the four numbers after the decimal point, did you?
Oh no.
You went with what? 12.12,
I think I did.
or what did we do?
Um,
Or 12.1? What? What did?
yeah, yeah, that's what I
Yeah.
did.
Remember, don't do that. Give all four numbers. Oh, we'll keep going. For
Okay.
the next for a bit more. So tan. So what do we do? So this is another similar question. So tan.
Tan is opposite over adjacent.
Okay, tan z. The opposite is
So opposite is 72.
adjacent is missing, isn't it? So
Yeah.
okay.
So what we would do is c squared minus a squared equals b squared.
Mm-hmm.
So c squared is 97
Mm-hmm.
squared, and then a squared is 72
Squared. Mm-hmm.
squared. Yeah, so 97 97 squared is 9,409.
9,409.
Yeah,
Okay. Take away 72 squared, which is
72 squared, which is 5,184.
okay.
So 9,409 take away 5,148 is 4,261.
Okay, so find the square root of 4,261, did you say?
Yeah,
Okay.
so the square root of 4,261 so 65.2763.
65.273.
63. Yeah,
65.2763.
yeah.
You need to write it as a whole number. Wait,
Okay, so
what did you say? Yeah. I think this is asking. You can put it as a whole number here. Is that right? I'm going to say a whole number.
yeah,
So,
so that would be 65.
mm-hmm. Oh, so 72 over 65. And can we, I don't think, can we simplify it?
No.
Well done. Okay, and, okay, so
Because
sine.
is opposite over hypotenuse.
Okay, so opposite is 15. Hypotenuse is missing. So we need to find out.
Yeah. So we would do b squared minus
No,
a
no,
squared.
no, we wouldn't. It's the Pythagoras' theorem. I was about to say Hippocrates' theorem. Pythagoras' theorem. So a squared plus b squared.
Oh yeah, a squared plus b squared equals c squared. So we would do 15 squared
Mm-hmm.
plus
Mm-hmm.
8 squared. So 15 squared is
I need to get my charger. Yeah. 15 squared. Sorry, Mahdi, I'm just going to mute myself here, okay? Because I'm going to get my charger. So I'm just a minute. I'll let you work away on. Can you? Are you able to see the question still?
Yeah.
Okay, I'm just going to mute here. Okay. I need to get the charger.
You need to sort out your books. Or I'll just lift them,
Right,
start
okay.
lifting them, and empty the fridge.
Do you have Coke in there?
Yeah.
Can I have one?
There's a whole lot coming on it. It's not been along for you all.
Thank you very much. All right, thank you. Okay, how's it going, Mahdi?
Yes, going good. So
Okay, I just had to get the laptop charger there. Do you want to keep it going until 8:30?
yeah.
Okay. So what have you found? What have you found out
So
now?
I found I got 17.
Okay, so the hypotenuse is 17.
Yeah.
The length of it is 17. Can we simplify it?
No.
No. Okay, so we'll submit it. Okay. And okay. So we've got the lengths, which is great. We don't need to do Pythagoras' theorem, but we do need to know how to work tan. So, how do you
So
work that? Like,
tan is opposite over adjacent.
okay. Opposite
So
over.
okay.
Okay.
So what we would do is um, adjacent is 2
They're both going
on
to be
the
two. Mm-hmm.
2 on the left. So K to J.
So opposite over adjacent, yeah. So opposite is 2. So um, IJ and KJ,
Yeah. So
2 over 2. Okay.
so IJ is the opposite,
Mm-hmm.
and then the adjacent is KJ.
Mm-hmm. Which is 2.
Yeah.
So what do we do now?
So now we write 2 over 2,
Mm-hmm.
and then
2 divided by 2.
2 divided by 2 is 1.
So would that be the answer then?
Yeah.
So it's not. Okay, let's see. It says to the nearest 100. Let's see if that's correct. It is. Well done. Okay, so let's keep it going. So,
So again, it'd be the same thing. So opposite over adjacent, and opposite is T to U, which is 7,
mm-hmm,
and then adjacent is V to U, which is also 7.
mm-hmm.
So 7 divided by 7 is 1.
Okay, so the answer is 1. Well done. Okay, now they're getting harder. So COS.
So cos is adjacent over hypotenuse.
Mm-hmm. So adjacent would be.
Um, adjacent would be square root 41,
Mm-hmm. Yep.
and hypotenuse would be 7.
Wait a minute. No, it wouldn't. No, it
Oh
wouldn't.
no, it'd be the missing side.
Mm-hmm. We need to find out the length of TS, the
Yeah, so
hypotenuse.
what we would do is find what 41 squared is.
Mm-hmm. Well, first of all,
So,
the square root of 41. Do we do do we find out what that is first of all, and then multiply the numbers like we did before with the last example or the last question? So what's the square root of 41?
square root of 41 is 6.4031.
Okay, multiply it by itself. 6.4031.
Okay, so 6.4031 times 6.4031
Mm-hmm.
is 40.9996.
Okay, keep those numbers. 40.999. Did you say three nines or?
Yeah, three nines.
Okay, 40.9996. Keep those numbers. Uh, so it's now what you need to do is
Is round ups.
well add 7 squared.
Oh, okay. So 7 squared is 49.
Okay, so add them up.
So would I round up the 90.9996?
Well, I would actually keep it as it is because it might affect it might affect the
Oh, okay.
we're going to round up the length of hypotenuse anyway. Or wait a minute, I think that they actually kept the four numbers. They only rounded it up at the very end when you were finding out the answer of cos t. That's when you round it up to the nearest hundredth. Okay.
Okay, yeah. So
Keep
it's 139.9996.
okay. What do you do now? You square root it, don't you?
Um,
Oh, wait a minute. What seven square? What is? Where did you get that from? Was that
so
when?
I did. Wait, was I supposed to
Yeah.
times the 90.9996 times 49 or add them?
So so for the Pythagoras theorem, you add
Oh, okay, yes.
add them up.
So I got 139.9996 by just adding the two numbers.
Okay, and now you have to find the square root, don't you?
Uh, yeah.
Okay.
So the square root of 40.996 is 6.4030.
You see, it's longer. I'm just thinking that that number might not be right because that the length of a hypotenuse is longer than RS. Okay, so
Yeah.
let's do it a different way. What if you do what if you do square root 41 squared? Can you do that? Can you do that? Or
Square root 41. Uh,
you've done something?
squared.
Yeah.
So yeah, I can do it.
And what do you get?
41.
Okay. Now we'll need to try because the hypotenuse is longer. You see, 40. So you got 41. You square rooted it, and you got 41. Okay. And then
Yeah.
what about plus 7 squared?
Plus 7 squared is
Mhm.
49.
Uh. Okay, so that would equal the length of the hypotenuse, wouldn't it?
Um,
Now you need to square root what did you get? 49? No. So you got four. What's 7 squared? 7 squared is 49. Did you say?
yeah.
Right now,
Yes.
Now what do? So you've added them up. You've got 49, so now you need to find the square root of 49, don't you?
Yeah.
Yeah.
So square root of 49 is 7.
Yeah, so that's a bit better. They must be the same length. Hypotenuse, okay, I don't know. Right, so now what do?
Now,
You've got the length of the hypotenuse.
yeah, so now we would
Divide so what's cos again?
so cos is adjacent over hypotenuse, so we would need to find out what 41 squared is now.
No, you divide. Do you not?
All it squared, the square root of 41.
Okay, I think you've done something wrong. I don't know. Because you said square root of 41 squared is 41. You've done something wrong. I don't know, but you got set. So you divide. Okay. So if you put it as square root of 41 over 7, yeah,
Sorry?
for the equation to find out the number, so it's square root of 41 over 7, isn't it? So you divide them, don't you? So you divide square root of 41 by 7.
Yeah. Square root 41. 0.9147.
147. So now we need to do it to the nearest 100, don't we? 100. So it'll be
Yeah.
0.91. Right. Sure, they'll give us the answer if we didn't. Sorry, about 2 seconds. What did we do wrong here? Oh, okay. So yes, you square root it. You got 41. Okay, yeah. Did you
Yeah.
get 49? And you got 49. Okay, but
Yeah.
but when you add them up, you get 90. Did you get that?
No, I don't.
Did you miss that one out? That bit out?
Yeah, I think I missed that one out.
Right. So when you're, a squared plus b squared equals c squared. I think. What did you do instead?
Um, I just think I didn't. I think I just skipped the adding up and just moved on to the rest of it.
Okay. So you add it up, and then you get 90, and the square root of 90 is 9.4868 for the length. Okay. I thought there was something wrong, because the hypotenuse is always the longest length.
Yeah.
So
Could you go up to the Pythagoras theorem?
mhm.
Yeah, thank you.
Yeah, write it down, and then that'll give you a better idea. Okay. Okay, and tell me when you want me to scroll down further.
Yeah.
Mm-hmm. So 9.4868. Take the formula for the cosine of LT and plug in the relevant side lengths. Okay. All right.
I'm just writing the writings on the side. So just like the plug-in RT equals,
Square root of 41 and RS equals 7. So you add them up. Well, you need to find out what the square root of 41 squared is, and that's 41, because that takes basically the square root of 41. When you square it, it just becomes 41. You take away that square root by doing that. If you do it by okay,
Yeah.
and then 7 squared is 49, and then you add them up and you get 90. Uh,
And then
then you then to get the length, you find the square root of 90, don't you? And you get
yeah.
9.4. Yeah, 9.486 or 9.4868. Okay.
Okay, I've written that down.
Now you see for the next bit, when you're when you're taking the formula for the cosine of LT and plug in the relevant side lengths, all you do here is find out what the square. Well, what did they do here? How did they get 6.4031? Did they find the square?
So yeah, they found the square root of 41,
Mm-hmm.
and then I think they just left the 9.486 as it was.
For what is that? Is that the length of the hypotenuse?
Yeah, the hypotenuse. Yeah.
Okay, and they divided them. Uh,
Um, what did they divide them by?
they divide the numbers.
Oh, okay. Yeah, I see. I
So
see.
could you try? Do you want to do that quickly? Do you want to do that on your calculator?
Yeah. So 6.4031
Mm-hmm. Divide it by.
divided by 9.4868. So that's 0.6749.
And what did they do then? So nearest hundredth. So the 4 is what is big or small? Too big,
Small.
too small to round up. So it would be
Yes.
0.67. Right. Okay. Now I see the time. I see the time. Um, and I'm hoping the lesson has helped a little bit with
Yeah.
not a big bit actually. But I think we need to do more of this on Monday.
I think we won't be doing trigonometry like
Oh
this.
no.
I think
Okay.
it's just going to be I think it's just going to be like just
Is that too advanced then? Are you saying that that's
yeah,
too advanced?
I think that's too advanced. I think we should move on to a different topic now.
Okay, the screen's frozen. I think. Did you find out what? Okay, so that. Thanks for letting me know.
Yeah.
About that. But there's so many different topics that we could cover. Let me just see. Can I just give you a quick glance of the IXL? Because this web's sorry, 2 seconds. Because for Monday, I mean for Monday at 7. I think because we really did exhaust the questions there, but I think yeah, right. They do seem more advanced, like for A level, I would say. A level maths, some of those questions.
Yeah.
So see for
I
Monday.
have the
Hmm?
yeah, I have the list here so I can see what
Okay.
I think we should
Well,
work on.
well,
So
call some of them out because we need to see if this website has them. Here.
so
So, what have you got on your
uh,
list?
expand and factorize.
Expand factor. Okay. So factor. Okay. So it's expand and factorize. Um. Again, there's so many. Factorization. No, that's okay. So it wouldn't be that. Expand and factorize. What else is there?
Um, Hold on.
Hold on, I'm just as well. Oh, factorizing. Factorizing quadratics.
Um,
No, was that
yeah, I think it's that.
okay? So there's factorizing there. T under T factorizing. Mono meals.
Also,
Mm-hmm. Are you looking on the WhatsApp? Is there? Did you say there was a WhatsApp or something?
no, it's an app called Weduck. It's a school website.
Weddock. Okay. So if you could just quickly, so we can do the factorizing on Monday.
Um,
Factorizing quadratics and
ratio proportion.
okay ratio. Let me just. I'll do it. Press. Oh. Simplify. No ratio. Oh, here. Well, we looked at trigonometric ratios, but oh, here. Ratios, rates, and proportions. So identify equivalent ratios. Write an equivalent ratios. Does that look familiar?
Um,
Ratios.
yeah,
Okay, so yep, we've got something for that. Is there anything else?
and no, I think that's it.
Well, I think that would take plenty of time. And then listen. So so on Monday you want to do look at the ratios and um you want you don't want to do the trigonometric ratios anymore.
No,
You want to do, but you want to look at ratios.
yeah,
Yeah. And you so we've got two things to look at for Monday: factorizing and ratios. Okay, that's brilliant. I'm so happy that you've given me those two things to look that we can look at. Okay, sorry for the going way over time, but listen, I'm sure you'll sleep very well. Did you? You're probably exhausted now. Go back to bed and rest because I think your mum was telling me you were sleeping before the lesson. So, yeah, rest well, and I look forward to the lesson on Monday. Okay.
yeah.
Okay. Thank you. All right. Bye
Thank you.
then. Bye, Maddie.
Bye.
Bye.